let's take a look at the 3D graph of x squared plus y squared minus c squared equals 1, and then how that relates to this concept of level curves of a function. So if I take a look at this graph right here, specifically if I want to envision the xy traces, then I can think of it as, what if I plug in different values of z? Like, what if I plug in z as 0? What if I plug in z as 1 or -1? What if I plug in z is, I don't know, 2 or -2? What am I getting? So if I plug in z as 0, then I end up with x squared plus y squared equals 1, which is going to be a circle of radius 1. If I plug in 1 or -1 for z, then I end up with x squared plus y squared equals 2, which is going to be a circle of radius √2. And if I plug in 2 or -2, I end up with a circle of radius √5. So these aren't the prettiest radii, but this is what we get. And we were picturing this on a 3D graph as this hyperboloid of one sheet, where sort of this middle, right on the xy plane is the circle of radius 1. And then we have, when we're going up to 1 or down to -1, it gets a little bit bigger. And, as we continue to move away from the origin, it continues to get a little bit bigger. And there's a symmetry there that I'm capturing with the different colors. So this is a hyperboloid, remember, of one sheet. Now, the YZ traces and the XZ traces were hyperbolas for this. But I actually want to really focus more on this concept of the level curves. If I take a look at the level curves, specifically level curves for different values of z, then I'm going to actually say, let's suppose I took all of those different circles, the green, blue, red, and sort of collapsed them down so that they landed specifically on the x, y, 2D coordinate grid. So that would not really have any impact on that first circle of radius 1, but what it does is it now sort of stacks all of the other circles on top. So square root of 2 would collapse down, be a little bit bigger. I'm not going to really worry about scale. I'm just kind of showing that we end up with these different circles. And each of the circles goes along with a certain z value. So the red circle goes along with a z value of 0. The blue actually goes along with both plus and -1. The green goes along with both plus and -2. And there's no rule saying, for example, that I couldn't plug in a non-integer. I can plug in any value I want as my value for z. All of them are allowed. And so what we end up with now is this picture of what the different cross sections are, but they're all stacked on top of each other. Now we're going to take a look at this in more depth in a future lesson, but just for now, to make that connection here, the level curves for z is where we take all of the different traces for z that we might identify and just, take a few of those and stack them on the x, y coordinate plane, and those would depict the different shapes that we would get on the different planes as we do cross sections at different values of z.